Hello and welcome to Electronics 7. So I'll just put the title in there. And let's get going with Electronics 7. So I wanted to think more about the motion of electrons now. Okay, so I've explained what the differences are between obviously conductors and insulators, and how they're not always the same. How, for instance, I made an analogy with light and also with water flow in the previous episode. Watch that. So what I wanted to think about now is that in general we say so free electrons in a conductor have random motion. With no particular direction or speed. So obviously that's not the ideal case. So what we need to think about now is to actually think about how to coordinate this. And we know that electrons can be kind of influenced or controlled, perhaps, can be influenced to move in a coordinated manner. Through a conductive material. Okay. So yeah, let's think about how this works, because the thing about electrons is they move in a sort of uniform way. I like to think of a bit similar to kind of the way ants move when they're carrying a leaf or something. You see a huge leaf and there's about 1,000 ants underneath it. That's how I kind of see the movement of electrons. So the uniform motion of electrons it's called electricity. Or electric current. Okay, so this is when we start really starting to think about electronics. Electric current. I can underline electricity as well, why not? So at the beginning, of course, we spoke about static electricity. So what's going on here? So this is like dynamic electricity, because it's coordinated. Because static electricity, you recall, is simply an accumulation of charge. So static electricity, let's get rid of that, accumulation of charge. This is much more. I can't really put much here. Just much more dynamic transference of charge. So this is obviously what we're going to be dealing with, dynamic electricity, and it makes more sense to deal with dynamic electricity because it's easier to. It's much better to control, and obviously it's the way that a lot of the systems operate. Okay, so let's just recall. So this conductor, the metal conductor, keep in mind, is it's still like any other object, it's mostly empty space. I've said that a few times before, but it still works. So the electrons. So you can just imagine that it's like, if we've got like this thing here, then we could just imagine there's just little points. It's still mostly empty space, and these are the only bits of solid. But obviously, you've got all the protons and neutrons which are keeping it to be this material, this element. But all these electrons within the conductor are moving around. Yeah. So it's, yeah. So the motion. And the motion of electrons through a conductor is referred to as flow, and that goes in line with what I said about the analogy to water as well. In episode 6, you can check out that one. Okay. Okay, but how exactly does this work? This flow? So yeah, let me just write it again here. So as each electron moves uniformly through the conductor, it pushes on the one ahead. So we can have, say, some dominoes here or something. It's going to push this one. I don't know the way around there. I need to get much better at my 3D drawings. I think I might be able to. That's not bad, cuboid. So it's going to push the next one along. Push the next one along. And it'll put dot, 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 dot. So the electrons move as a group. And again, it's similar to the ants. I like thinking of it like ants. Okay. And the important thing to mention is the starting and stopping of electron flow is almost instantaneous. And it's because of this system that's being used. It's almost instantaneous. And this is quite an interesting thing, actually. Actually, I'm just going to continue this sentence from one end of the conductor to the other. Yeah, this is what I'm going to write. One end of the conductor to the other. But the motion of each electron can be slow. very slow. So one good way to visualize this, if we say have a marble here, and then we have a huge tube full of various other marbles. Good way to look at this is when this tube gets inserted into here, this tube is also going to go here, it's going to push this, and then obviously one of them is going to come out the side here. That's what's going to happen. So similarly, we can say that so for instance, so here we can say even though each marble only moved a short distance, the marble on the right came out almost instantaneously. So yes, this is because of the speed, and the analogy to actually conductors is because of the speed of light. And yeah, so it's not going to matter how long this tube is. If these are, it can be seen as an electron going through, because this is going to come out instantaneously. So that's how we can communicate quickly over like long distances and things like that. And keep in mind that each individual electron travels through the conductor at a slower pace. Okay, and I think that really that was all I wanted to. So yeah, so the conductor is so these can all be seen as free electrons.